All right, so now Isabel and I will go through and set up an example system here. So we'll take a look at what we have. We have a gateway here that collects data from our vibration and temperature node that sits on a motor. We have an example motor that's just a 1/4 horsepower here today, hooked up to a VFD. So I'll go ahead and power on our gateway to where we can start to see data come in. So you'll see if you look at the maintenance hub that Isabel has on her screen that it's showing 0 of 2 active. As this gateway comes online, it'll become active, and then in the next couple minutes, we'll see the VBT come online, so our vibration and temperature node. A little bit on the hardware there. So it is a triaxial accelerometer. It has a magnetic base that we're using to connect to the motor itself. And it has a battery that you can put on there with 3 Torx head screws. So in about 3 years, if you're at 1-hour intervals, you can easily replace that in the field. Our gateway here is actually what we call a ComboGate. So a ComboGate has a connection to our cloud. So the maintenance hub that Isabel will show. So that's via LTE in this case. We also have Wi-Fi as a available option. And then the other part is a connection into Studio 5000 via an Ethernet IP connection. So that's our kind of control side. So you can have both of those in one unit, which is a unique feature that we offer. If you just wanted to have cloud only, you can do that. And if you just want to control only, you can do that as well. So with that, I'm going to go ahead and start up the motor. So we don't have any defect on there. It's kind of just a motor sitting on the table that we have clamped down. Later in the video, I will introduce a defect, or you can see what that looks like in the maintenance hub using an eccentric load kind of puck. So let's go ahead and get that started. All right, so now that we have it going, I'll have Isabel go ahead and walk you through the maintenance hub.
All right, so here we are on the hub. As we can see, the nodes that Bryce just plugged in already connected. So we have the first one, the part number, EIP, the serial number 1D0008. That's the CloudGate we have here. And the VBT that's sitting on the motor. So you can see all the details about it. We will go back and go over those channels in more details, but first let's get our system set up to start monitoring vibration. So we get into this vibration analysis page, and we are going to create an asset. So the motor on our table is our asset. I'm going to call it test motor, for example. You can pick what kind of motor you are dealing with here. I'll just pick, let's say, fan blower shaft. And you can pick what kind of vibration analysis you want. We have several options to pick from. For each option, you can see what bands are enabled. Or you can completely customize by using advanced VBT, which bands you want to monitor. So you've got the XYZ bands for each axis. You have 8. Yeah, at 8. The overall subsynchronous, 1 times the RPM, 2 times, 3 times. You've got the bearing band, the low harmonics, and the high harmonics. And for each axis, you have got both amplitude in inches per second and frequency in round per minute. And we got additional bands here for special cases, the gear blade frequencies, but we're not worried about those for this demonstration. We will pick a basic analysis type. And so here's the other settings. You can decide how often you will sample data. Here for this demonstration, we'll pick 1 minute, and can enter the speed of your motor. 1800 is kind of our default value we'll go to, but this is customizable, and our acceleration range, depending on what amplitude of vibration you're expecting to monitor, you can adjust the scale. Here we will stay at 2 Gs. So now moving on here, you can see you can recognize the serial number of the VBT we have currently on our motor. And we get to decide where it's placed on the motor. So all you have to do is drag and drop to, I would say, right now it's sitting here on the motor. So this is the most accurate place it's at. And then additionally, you can adjust the alignment of the axes. So X, Y, and Z, how does that align?
Yeah, so the X, Y, Z, I'll show you on the motor here. So if you get close up, you'll see the X-axis runs with the length of the sensor. The Y-axis is on the short side, and the Z-axis comes out kind of through the battery. So the way it's set up right now is appropriate. So we're good to go with that. But that is key to, especially when we talk about defect classification moving forward in the future. We want to make sure that we can identify what axis the fault is occurring on, because that will help us determine what are the likely failure modes for that orientation.
Yes. Thank you, Bryce. The second one we have is the alarming. So for the overall band, those are the default values we are going to set. We have 2 levels, the warning alarm and the danger alarm. Our typical values, those the typical values you usually have?
So the values that we have here are all the different machine types that you saw before as Isabel was walking through have their own unique thresholds that are determined by ISO from all of their various testing that they've done. So we're not reinventing the wheel here. We're just starting at a point where there's already a lot of data gathered. Let's use that to get a starting point, and we can adjust as we move forward. So for this particular fan asset, those are the thresholds that ISO said are appropriate.
Yes, so yeah, let's just stick with those example values. And as for the alarm settings, so we are going to, for example, have it send an email. It's already previously set up in the hub, so that if the data crosses any of those thresholds, Bryce will be notified by text or email.
Yeah.
So now I think we are all set with our asset. We just have to click save. Asset is created. And now coming back to our vibration analysis page, we can see our test motor is running, is currently online. And all is good. It's a healthy motor.
Yep, so it's all green here. If we go to the ellipses up there, we can get into a tighter view of it. So click down below, Isabel, right here, and then go to the view. So this view page gives us a better detailed view of what's going on with this asset. So if we were to expand the position 1 that it's, or position 2, sorry, that it's on, we can see these are our current values. So let's go ahead and I'll turn off the motor. And now I'll introduce our defect. So once again, it's a kind of a puck that we have off-center to where we can get an eccentric load. So I'll put that on now. All right, so now we've started the motor back up with that load.
All right.
You'll notice we have all this foam under our CloudGate and the laptop because of the shaking it is doing on this table.
Yeah.
So
while this is running and data is being collected, let us go back to the main dashboard. So the diagnostics has the voltage the CloudGate sees, and then two different signal strengths. As you can see, the first cellular is the LTE signal strength it sees, and the wireless one is the Zigbee communication to its VBT. And similarly, on the VBT side, you can see the signal strength that it sees from communications with its parent, the ComboGate, and the battery voltage, and a couple more diagnostic channels, error codes, and boot up values. Now, if you expand the vibration section, you can see that data is being reported on all of the channels that we have enabled previously when we were setting up the asset. So as you can see, it's mostly green so far. You have, apparently we're picking up a little extra vibration in the y-axis. This is just the most recent value. If you hover over this trend icon, you can see when was the last time a data point was received. But if you'd like to go into further details, let's see, we can pick the overall channel, for example, and see a time history of that specific data channel. Right now, we just turned it on, and we only have a few data points, but you have different views where you can zoom in into a specific time slot quickly. Additionally, you can add extra data channels to this plot, up to 5. So let's see, we have a Z. It'd be interesting to add the y-axis overall, x-axis. Let's just keep those 3 for now. And then drag and drop, not drag and drop, zoom in to a specific point, and you can hover over to see each individual point. Right now I selected the amplitude, so it's in inches per second. And as data is being collected every minute, you can keep on refreshing this page and see the new points come in. So here in a little bit, we should start to see this data go up the next minute. So while we do that, while we wait, oh, here it comes. You start seeing a lot more red. So specifically, we've got extra vibration in the, we're up to 1 inches per second on the y-axis, and you can see that reflect on the overall band that includes all the other bands. And it looks like a lot of this vibration is also in the subsynchronous band. Was that expected from the puck you added?
Yeah, with the amount of vibration we're seeing, it's definitely gonna travel across some of the other bands as well. So let's go ahead and take a look at the asset view while I go ahead and shut off this motor so we don't have to keep shaking around.
Yes, please. Back into this page. So you can see in the asset view, things have turned red.
Yep. So that basically, you have your little indicator there of your health at a quick point of view, but let's go ahead and dive in and take a look at what we've seen.
So going into the details of what happened. So clearly the vertical axis will be our Y, where we were seeing elevated values when we were on the dashboard. And see, you can see here those 1.06 inch per second are showing up as way above our danger threshold level.
Yeah, let's go ahead and now that Isabel's run through some of the Maintenance Hub stuff, let's take a look at what we do to set up, now that we're set up in the cloud, to get set up in our PLC.